Hello and welcome to our third video in our Advanced Trigonometry series. I'm Mr. Chowdhury and today we're going to be looking at Pythagoras and Trig in 3D with a focus on Pythagoras for this particular video. So before we do anything, I suggest you go and watch our videos on Pythagoras and Trig recap so that we're all up to speed before you do something a bit more applied. Now, the key thing when trying to do Pythagoras and trigonometry in 3D and where most students go wrong is trying to identify where the triangles are. So here's what I'd like you to do. I've given you 4 different triangles up here, and all I want you to do is try and figure out where these triangles are on this cuboid. So where are these triangles? Where would they be on this cuboid? And I'll do the first one for you. So if we look at triangle EAF, that means we're going from E to A to F, and it would look like this. And once you've done that, what you want to do is tell me what the lengths are. So I know EF here would be 3 because it's written there. So I know that's 3. And I know that AF is 4 because it's told me here. So I've written 3 and 4. And then I can use Pythagoras to work out what EA is, which in this case is 5 because 3 squared plus 4 squared, and you square root that, and that gives you 5. So here's what I'd like you to do. I'd like you to pause the video right now. Try and draw in these triangles. If you're happy with where you've drawn them in and you think they're in the correct place, then pop the lengths on there. This should take you about 10 minutes. If you finish quicker, that's fine. Just unpause the video and carry on. Okay, so we've done the first blue triangle for you. Now let's have a look at this green triangle. So the green triangle is EHG. So I'm going from E to H to G, and that would be this one, the one on the floor of this diagram, that one there. So you can fill in the lengths. So I've got 3 and I've got 5. I need to work out that using Pythagoras, and I can work it out as 5.83. 5.83. So that's the green one done for you. Now let's try and find out where the red one would be. That's E to D to H. So that's E to D to H. So that's going to be the one on the front panel here, EDH. So we work that one out. Height is 4, base is 5, and I get 6.4 as my diagonal. And the last one, and possibly the most difficult one, is AFH, and that would be here. Now to work this one out, we need to do some extra a couple of steps. So I know what AF is, and I know that's 4. I need to work out what this diagonal is. Well, luckily, we've already worked out what that diagonal is when we worked out what EG was. Right? EG is here. We worked that one out, so I can put that on the diagram because I've already worked that out, because EG is the same as FH. They're both the exact same because they're on the bottom of this rectangle. They are diagonals in the bottom of that rectangle. So then once I know what these 2 lengths are, I can work out the other one, which is that. So hopefully that helps with just identifying where the triangles go. And we're going to use this in a bit more of an applied sense. So here is another couple of questions. We're going to have to try and work out some areas. Remember, we said we were going to focus on Pythagoras because I think the key to this, as I've said already, is to be able to identify where the triangles are. Because once you've identified where the triangles are, you can pretty much do anything with that triangle. You can manipulate it however you like. You can use trigonometry, you can use Pythagoras, whatever you need to do, you're going to do that. So pause the video right now, give yourself 10 or 15 minutes to try and answer all of these questions. Right, so there's going to be a lot of Pythagoras being used here and a lot of prior knowledge from previous questions. So we'll work out what AC is. So I've got AC there. Just use a bit of Pythagoras and I get that answer. BH is that line there. I can see my right angle triangle and I get that answer. Then I'm doing DG, which is our space diagonal, the one that goes across the entire cuboid from one point of the cuboid to the other point of the cuboid. My triangle goes down to E and across to G, so I'm going EGD. There's my triangle. I'll have to use Pythagoras to work out EG, then I'll have to use Pythagoras to work out DG, so I end up with that one. Now these ones are a bit more difficult, so let's have a go through these ones. So the area of the triangle FCH, so I need to draw that in. FCH looks like that. So I need to work out the base and I need to work out the height. The height we're given, 6.5. I just need to work out the base by doing a couple of calculations. Luckily, I worked out what AC was, and FH is the same as AC, so I can just use that number there, and I get that as the area. The next one is this one. Once again, I've worked out what BH is. I know what AB is, so I can use those two lengths to work out what the area of that triangle is. And finally is this one. And I've already worked out what DG is, so I know what EB is, because they'll be the same. And I already know what BH is, so I know AE is the same, so I can use those values to work out what EB is. Right, this may have seemed like a very short video, but I really wanted you to focus on being able to draw those triangles in, because once you can draw those triangles in, answering questions isn't too difficult. So what I'm going to do is I'm going to link you to a video created by Mr. Amerson, which should help you with a bit more practice with applying Pythagoras and Trig in 3D, and hopefully that will build your confidence moving forward. If you're happy and you think, right, I can go and tackle some questions without the help of Mr. Amerson, that's fine. I suggest Dr. Frost and Corvid Maths as usual. If not, feel free to go watch Mr. Amerson's video, which will give you a bit more support and a few more worked examples. I just wanted to focus on drawing the triangles. Where are the triangles in this diagram? Hopefully that's helped, and I'll see you in the next video. Go off and be productive.